Our student, so yeah, welcome to the RS1000 again. And then we have finished half of it. It is already week 7. And then we have finished the basic parts of the AI 1000 artificial intelligence and data analytics in health science. So we have covered the fundamental theory part, and then we have covered the supervised and unsupervised learning. So supervised learning, so we have learned the um, classification and also the questions. And for the unsupervised learning, so we have learned the clustering. And for the dimension reduction and then the other hopes that you, when you go deep into the RS1000, you can learn more, and learn more. And then after the fundamental part of the RS1000, and then we will go to the application part. So as you are the health science student, we are not going to teach you anything that relate to development or relate to the programming part. So yeah, as I have promised right now, I guess it's zero programming. For the Excel or other things, it's only writing, copy and paste some of the small command into the field cells. So I guess it's not it's not a programming. Yeah, I hope that it's not too difficult. And yeah, for this part, starting from this part, so we're talking about different kind of application, talking about VR, AR, chatbot, wearable device, etc., and then how they can use in health science or the other domains. So I will also let you know some of the example. We will talk about the hardware, we will talk about the software, we will talk about the technologies behind, but no program will be involved and no human kids will be involved. Or if you want to do some demo and then you can try something, that's good, but it's not a must. So yeah, that's the situation. And then we have received your feedback about our first part. So we will reduce we'll decrease the amount of the online and also the face-to-face exercise so that it keeps you a little bit easier because when you go to the with 7, 8, 9, 10, etc. So most likely it's your midterm. So you can put more effort in the other class and then here. So it's only the applications. And then for your project, most likely we only request one idea. Okay, one idea. So we request an idea that how the AI can be put in the health science, and then you prepare a PowerPoint slide. If you have a little bit prototype, then that's great. If you do not have a little prototype, still you can pass this subject. So yeah, for the prototype, perhaps you can use the VR, AR, or all sort of things that we have learned in the later part, or somehow you can still use the packaging phase or use the Google Teachable Machine or Excel. Use this kind of thing to visualize or to demo your thinkings to visualize your idea. So that is the situation that we are going on. So yeah, let's continue. The first application will be mixed reality. So mixed reality, talking about the VR, virtual reality, and AR, augmented reality. Both of them, yes, they are my expertise. Okay, so the start of my rehabilitation project goes to VR, and this kind of VR is part of the mixed reality. So mixed reality, or in another word, some of them say that it's extended reality. So in my definition, both of them refer into the same meaning or similar meanings. So we say this one, mixed reality, or in another terms is extended reality. They are the superset. Superset, that is the bigger set. And inside this bigger set, you have the VR, virtual reality. You have also the AR, augmented reality combined together. So they are the mixed reality or extended reality. So how to define the virtual reality or augmented reality? So here comes to a better graph to visualize all the things. In our world, we are living in a reality, okay? We are living in a reality. So reality, our objects are we guys, human, and then we are living in a physical world, okay? And all the interactions is implicit. That means that when I'll say that when there is a physical object, here is a bottle. So when I touch it and then I pick it up, there is no wording say, hey, this object you can pick it up. Or in a easy understanding, right? When you are playing the video game, when you are playing the PS5, etc. Some interactivable, touchable object. So you will have some special effect, and then when you touch it, so there will be some lighting effect or other things in the physical object. But in our reality, in our physical world, we do not have this kind of the interactions. All the things is implicit. So when you're born, you have to learn how to interact with all the physical objects in our physical world. So that is our learning process. So you know the reality, right? So now you know the reality. So when you are fully inside the virtual reality, that means all the things are artificial. All the things are not real. Okay, not all the things are virtual object. So what's the meaning? Means that, hey, you are 100% living in a virtual world. So what you can see, for example, you are wearing the VR device where you are in the VR head-mounted display. So all the things inside this head-mounted display will be virtual, will be generated by the computer graphics, will be generated by the algorithms, by the 3D model, etc., etc. So this kind of the virtual object is this kind of the virtual environment when we are putting we inside it is called virtual reality. So inside the virtual reality, so we do not have the concept of human because all the things they are avatar. So in your physical, in our physical world, so we can see our physical hand, right? But when you put the virtual reality, when you put the head-mounted display and then go to the virtual world, go to the virtual reality. So even your hand here is the virtual hand, is the avatar, is the 3D object, is the data. So that means that when you go to the virtual world, all the things that can represent you is not the physical human, is the avatar. And interaction inside the physical world is explicit. So similar, as I have mentioned before, so when you are playing an online game or when you are playing a PS5, so not all the objects, they are touchable. Okay, not all the objects, they are touchable. So some of the objects, they are touchable, some of the objects, they are not touchable. For the touchable or for the item that you can pick up, so there are some special effect, there are some lighting. And all the interaction, they are explicit, really clear, really easy to understand. So now you can, I guess now you can fully understand what is virtual reality and then what is reality. So augmented reality is in between. It's in between. That means inside the physical world, you want to put some virtual object to explain the physical world. Easy understanding is AR glasses or AI glasses nowadays. For example, later on we will discuss about the Roget. So the Roget, the Chinese company, so they are using the AR glasses. I will buy later. And yeah, this month should be this month. The Roget AR glasses I'll buy. So when you use the AR glasses to see the physical world, so when you see a bottle, it's still physical object. You still implicit interaction. So when you touch it, you do not have some special effect. But with the AR glasses, some label, text label, or some image, or some 3D model can be added on to this the object from this physical object. For example, I can add a word bottle on this physical object, and that is called augmented reality. That means I add some additional information to the physical world, and that is augmented reality. So for your understanding, so there are three this kind of the world. The first one is the physical world, reality. And then the second one is the virtual reality. All the thing is virtual. So virtual object is the major part. Augmented reality is in between. That means the major is still the physical world. The major is still the physical world. But you try to put some label or virtual object in this physical world. So somehow we give the physical world as the major, virtual object as the minor, supplementary object to describe about our world. So that is augmented reality. But honestly, for the VR and AR nowadays, yeah, it's a little bit blurred. For example, when you are using the Apple vision pole. So if you want to try vision pole, I mean, no, so I have some vision poles. And then in the IC, you also have some vision pole that you can borrow and try. Vision Pro, they can swap from the virtual reality to augmented reality, or somehow you can use your hand to interact with the virtual object. So you have the virtual object, but your physical hand. So it's a little bit in between the VR and the AR. And then today, some of the AR glasses, they also have the ability to fully convert into VR. So that is a little bit strange, right? And some of the, for example, VR locational based entertainment. So you can use, you are using the MR display, you are seeing the virtual world, but somehow you can still touch the physical object, interact with the physical object, and then get the effect from the physical world. So it's a little bit blur and then mixed with each other. And that's why we have another term, mixed reality or extended reality, to represent this, I would say the superset, and then represent this kind of bird concept inside our computer system. So yeah, starting from here, we talk about the VR first, and then we go to the AR, VR, and then we will talk about the hardware, software, etc., etc. But before all the things, so we let us talk about the concept or definitions of the VR, virtual reality. So as I have mentioned before, virtual reality is a computer-generated simulations of a three-dimensional entertainment. That means they try to use the computer graphics, and then they try to use the computer physics to regenerate our 3D physical world. So that is their ultimate goal. So that's why later on we want to do some digital twins. They have the similar thinking. I want to use the computer, human-defined technologies, to regenerate the whole physical world, to regenerate, simulate the lighting, simulate the physics, simulate all the things in our physical world, and that is virtual reality. So the ultimate goal is try to generate something that is 100% relate or 100% similar or looks similar to our physical world. So yeah, we can move around, we can walk around, we can interact with all the virtual object, we can respond to the action in real time. That is our definition. Or in a easiest way to understand VR is put yourself into a virtual environment. So that is the VR, that is the virtual reality definitions. A really simple sentence, put yourself into the virtual environment, then that is virtual reality. So to tell us whether you can understand a lot about the virtual reality, so here is a maze, right? So start point and then the goal. Try to find the shortest path from the start to the goal. So maybe you can pause the video here and then wait for 1 minute and then see what's going on. So yeah, some of you guys say that, hey, the shortest path should be from the start here, my pointer, start here, to the goals, right? So we need not to travel from the maze, so we can travel outside the maze and then use a 1, 2, 3, 3, 9, join the start and it goes together. But honestly, so if you because you guys get a higher grade in the public examination, so you guys are really familiar with the 2D, you can visualize all the things. But honestly, if you are 3D animals, if you are working, if you are still living in a 3D world, so the shortest path will be start point, end point, and then you flip the paper together. When you flip the paper together, the start point and the end point will become the same point. So that is the shortest path, and then that is the answer of these questions. So this small exercise tests you whether you are still a 2D animal or whether you're still a 3D animal, or you're familiar with examination, you love books, you love abstract graphics, and then all the things that go to the 2D. Because when you have the previous exercise, so somehow you will have you can recognize this is another kind of question that can test whether you are a 2D or 3D animals. So suppose there are three map representations. So one is here, 2D, and then another is 3D map. So if you are driving, for example, you use the Google Map or you use the 高德地圖. So somehow 高德地圖. So somehow you will fall into this kind of 3D world because it can represent better for the situation. So you know how far is your how far that you are going to your final destinations, and then what is the building on your traveling path, etc., etc. So 3D way, if you are driving, this one is better. Or some of the people will say that, hey, I want a better representation. So can I have a free AR view? So this one is 100% 3D world. Sorry, 100% 3D physical world. And then just like you turn on the camera, your iPhone camera, and then I put some virtual object marker label here to overlap the information. So A, B, C, 2D, 3D, augmented reality. So which one is better? Honestly, the answer is depends. So some of the especially about the boys, they will say that, hey, abstract graphic is better. Some of the girls, sorry about the sexual discrimination, but honestly, from the data of Google or Apple, is true. Most of the girls, they love this kind of overlap. So yeah, it's very clear. So what I see is what I get, right? So it's really clear information to the display. So whatever you choose 2D or this kind of AR representation, there is no perfect answer. It really depends on your background. So if you say that if you love science and then you want to get the information in a really get the information in a very short time without learning, then definitely you will choose here, this one, 3D overlap, abstract labeling with the physical world, because you need not to learn, you just look at the screen and then you understand what's happened. So this one is perfect. But you say that, hey, the information is too many. Here is the sense overload, or I would say that information overload to a well-educated person. Then some of them will choose 2D because they try to abstract out all the things and just give you the most important information to you. But honestly, this kind of the reading or this kind of learning, it takes time for you to learn. So it really depends on your target audience, whether you want someone that can get the information without learning, or you want someone that they are fully educated using this kind of 2D abstract graphics, and then they can understand the information in a really short time than 2D. Okay, similar things when you go to your textbook. So some of your classmates will really love the 2D textbook because here is really abstract. They try to highlight some most important information in a really abstract graphic. I can understand all the thinking in a very short time. But some of the classmates will say that, this one is the Microsoft HoloLens or using Vision Pro. I can have a 3D display of the human body anatomy, right? So you have to learn all the muscle and all the things later. So this one is better. And nothing wrong, nothing correct. So it really depends on target audience. Today you are lucky because when you are in the old time, so you do not have this kind of technologies, this kind of the computer graphics, VR, and AI. So we can only absorb the information from the book. So if someone cannot read, someone can understand the information from this kind of abstract graphics. So they do not have a best way for their learning. But right now it's better because we have the technologies, we have the graphics. But in another world, so if you give a professor an application for them to learn or for them to study, most of the professor they prefer 2D, they prefer paper, or even they prefer reading tasks rather than studying about the graphics. So yeah, that is the situation. So it really depends on your target audience and then what kind of information you are going to display to the user. But whatever, when you are considering to use the mixed reality, VR or AR, all sort of things. So the first one you have to concern is the user comfort, whether it's easy to use or is comfort to use the VR device. Some of the VR device they are really heavy, and then nowadays it's better because it's a standalone solution. In the good old time, so you have to use a wire to connect with the high performance computer, or you need to wear a backpack PC, so that you wear the GPU card, you wear the PC on your bed, and then you can enjoy. It's not so comfortable. Nowadays, it's better. And then even the AR glasses, at the very beginning, the AR glasses is very heavy. But as I remember, now the world gives AR AI glasses is only less than 50 grams, as I remember, 49 grams, something like that. So yeah, first one, user comfortable or not. Second, the amount of data to be processed. So you will always think that, hey, try to capture all the joint, all the information of the user, all the data that I can collect from the user, then it will be perfect. Honestly, if you are doing the research, yeah, it's perfect. But always remember when you have one more dimension of data you have to collect, so you need to have a better computer system to collect the data, and somehow you also need to have more computation power to process all the things. So yeah, if you have the money, go and collect more dimensional data. If no, the number of data that you have collect is a really big problem. So later on we will discuss why the VR device we will not use the motion capture data to capture the whole body. We only capture the hand and then the head movement. Because when we can reduce the number of data that we can collect, so it can reduce a lot of computation power and it saves your money. Then will be the because VR, right? So you want to generate the realistic 3D world, realistic environment. But try to imagine that when you are prepare a PS5 or PS5 Pro game, or you prepare the games that can be used in the Switch, they are totally different, two different world. On the Switch, so your computation power, the graphic is not so good, and then your computation power needs is not so high. So yeah, you need not to buy really expensive 3D display card to do all sorts of things. So you really have to think that, hey, should I need to generate a realistic world? The more and more realistic world that you want to generate, the more money you have to spend on the production together with the deployment, because you need a better computer system to render this kind of computers, this kind of computer graphics. Third one, deal with the real object as well as the graphical model. So how many real object that you want to deal with? So if it's 100% in the VR is the virtual object, then that's perfect. Somehow you say that, hey, I want to play the just like the VR theme park. So some of the 3D object, for example, the bottle, I would like to interact, and then yeah, I can touch the physical bottle. But in our VR world, so this physical bottle will generate another virtual appearance to the inside the game. So you have to put extra effort onto it. Lots of the health science or healthcare project, they want to interact with the physical object or with the physical world. So they have them special I would say that medical objective. So you have to do it. But always remember that when you have to recognize one more physical object, you need to put the marker. You need to have lots of the object recognition and object orientation. So you have to do more and more situation. So if you can limit the number of physical objects in your virtual world, in the virtual reality, so it will be perfect. Yeah, sometimes we cannot avoid, but when you have to do it, try to limit the number of physical objects that you want to do it. Then is the Then, because not all the virtual object that you can interact inside the virtual world, so you have to give some hints or visualization or the task over or somehow about the labels on some of the object that I can touch, that I can play with, that I can uh, interact with. So you have to give some hints to your user. Otherwise, yeah, your design will be another kind of uncontrollable environment. So when you are going to use VR to develop your clinical application or healthcare applications, always remember 5W. Okay. So yeah, what is the rationale? So why we need a 3D environment? Why we need a three-dimensional workspace within this application? Lots of the player 3D environments or lots of the clinical application 3D environment is not a must. Honestly, the clinical task, they only need a 2D environment unless you want to test, especially about the OT system, unless you want to test some working memory, unless you want to visualize or simulate their real world or the real world applications. Otherwise, 3D environment is not a must. Try to understand that if you want to pay a memory task, right? So just go to the convenience store 7-Eleven to buy a poker card, right? So using a poker card, you can also simulate the task of the memory, right? You need not to visualize all the 3D environment in the 3D world to ask them to remember the similar object or ask them to pay the poker card inside the 3D environment is a wasting resources. So always remember that give a strong justification why you need a 3D environment. If it can be used a 2D to do it, or you can buy the tools inside the convenience store or inside the Taobao or all sort of things. Just go and buy it to simulate the whole environment. Okay. So yeah, why you need a second W, why you need a immersive environment for your applications. So again, for the OT student, for example, for the dyslexia. So some of the children, so they cannot read or write Chinese or read or write English in a very good proper memory cognitive system. So perhaps immersive, so you cut the simulation of the physical world, let them to fully interact in the virtual world. It helps them to study, it helps them to understand the wordings. So Microsoft have done some similar research. So they put the Microsoft Word inside the simulate, inside the immersive environment. So you use your VR glasses and then to work with the Word document. So for the dyslexia student, they work better in this kind of environment because they cut all the physical simulate from their physical world. So we help. But as a normal people, so somehow I'm also working with PowerPoint, Word, Excel, etc. So I will not use Microsoft HoloLens or I will not use the Apple Vision Pro to edit the Word document inside the immersive environments. I would like to have a notebook or I would like to have a screen and then I can interact with other physical world. So second question is why your subject or why your target audience need a immersive environment for this kind of the settings. Otherwise, no need. Okay. Yeah, the third W, what is the sensing, motion sensing? You have to do it. Again, I can use the motion capture sensor to put as many marker as we can on my body to sense all the finger motions, all the joint motion, etc., etc. But as I have mentioned before, more data you have collect, more computation you need to do the processing. So try to limit the motion sensing. So most of the VR device now is hand and the head. But honestly, for the OT, they have or PT, they have some special need. For example, I want to trigger or I want to detect the motion of my finger. Every joint on my finger, I have to detect. So this kind of setting, you have to do the motion sensing on every joint. Otherwise, again, why we need to have it, okay? And then the 4W, what is the factor that contribute to the absence of such a solution? Yeah, if you can think about this kind of the need, this kind of the VR application, definitely someone in our world have the similar thinking. Okay, you are not so creative. So what we are going to do before we go to the development stage, we will search from the market, search the similar or same products or similar product that can fulfill similar objective about the clinical solution. Try to search first before you go to or jump into demand stage. Because when you jump into a demand stage, so even a really simple VR environment, it takes you, yeah, it really takes you about 1 million or half million to do the virtual world. So it's really expensive. Then the last W, why you have the ability to adjust this gap. Suppose that you cannot find the solution in the market, and then you have to build it, and then you have to ask why I have the ability for a development of this kind of healthcare VR solution. You need to find some computer developer. You have to find some expert in the health care team. At least you need these two people combined together, and then they can start this kind of VR applications. So if you do not, yeah, you are a healthcare science student, that's good. But if you do not have a programmer or developer that they know what is VR development, then you cannot start this kind of project. So before all the development start, always understand these 5W in your mind, and then why I have to start this kind of VR project.